Hi everybody. In this lesson we want to look at some inverse operations of squares and square roots. So let's look here at the square root of 4, which we know is 2. And if I square 2, I'm going to get 4 back again, right? So by definition, but the square root of 4 means the number that you square to get 4. So obviously if I square this number, that if I square it I get 4, I'm going to get 4. Now that's the same thing over here. If I have the square root of 2, I don't necessarily have to know that the square root of 2 is 1.414 something 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 and then square it again that I'm going to get 2. So the square root of 2 is by definition the number that I square to get 2. So if I square the square root of 2, I'm just going to get 2. And so what we're pointing out here is this square sort of undoes the square root in the same way that addition undoes subtraction and division undoes multiplication. All right, so when I want the square root of x plus 1 and then square, this square is going to undo the square root, and I'm just going to get x plus 1. All right, so again, the square undoes the square root. So we might ask the question, does a square root also undo a square? In other words, if I were to square an x value and then take the square root, would I get x back? Well, you know, if I square 2, that would give me 4, and the square root of 4 is 2. So it seems like that might happen, except when I come over to like a negative number. If I were to square a negative 2, well, that would give me 4, and the square root of 4 is 2, not negative 2. So notice that this square root right here doesn't exactly undo that square, because if it was to undo it, I would get a negative 2, not a positive 2, but if you square a negative 2, that's 4, and again, the square root of 4 is a positive 2 because the square root symbol always refers to the positive root. All right, so we have to be a little careful here. And the fact is that the square root of x squared doesn't equal x. That's a little tricky. What it does equal, though, is the absolute value of x. All right, so it will always return, right? The square root's always positive, and so if I have a number squared, even if it's negative, it's going, when you square it's going to be positive, and then the square root is going to return the positive value. And so if you put absolute values around x, even if x is a negative number in here, then this would be correct. All right, so when I go to simplify square root expressions, like say the square root of 25t squared, I can think of that as the square root of 25 times the square root of t squared. Now the square root of 25 is 5, and the square root of t squared, just like up here, it's not going to be t, it's going to be the absolute value of t. All right, so the correct answer here is 5 times the absolute value of t, and you can check that. Let's just imagine if t was a negative 1, so I'd have negative 1 squared here is 1 times 25 is 25, square root of 25 is 5. But if I put negative 1 here and I'd forgot those absolute values, I'd have 5 times negative 1, which would be negative 5, and that wouldn't be correct, would it? So I have to put those absolute values. Over here, this next example, that would give me the square root. Well, I'd square the negative 7, that's 49, and then I'd square the y, that's y squared. And then I'd do something similar to this one. I'd have the square root of 49 times the square root of y squared, and that's going to give me 7, not y. The square root of y squared isn't going to be y. The square root of y squared is going to be the absolute value of y. Okay? Let's do another one. If I had the square root of a minus 1 squared, well, the square root is going to kind of undo that square, but you have to put absolute values around the a minus 1. Again, just imagine if a was equal to, say, a negative 3. If a was a negative 3, you'd get negative 3 minus 1 is negative 4 for this part. You'd square it, that would give you 16. The square root of 16 would be a positive 4. So if I come over here and put negative 3 in, negative 3 minus 1 is negative 4. Well, if I forgot the absolute values, then I'd be saying a positive 4 equals a negative 4, and that wouldn't be correct, would it? So I need those absolute values to lop off that minus sign. Over here, this would be, notice that this is a trinomial that can be factored. And so when I factor that, that would give me x minus 2 times x minus 2 that I can then rewrite as the square root of x minus 2 squared. And again, the square root of something squared is going to be your something, but you have to remember to put absolute values around it. Okay? Let me do just 2 more examples here. If I had the square root of x to the 10th, notice that I could write that as the square root of x to the 5th squared. And so the square root would undo this square, and that would give me, again, the x to the 5th, but I'd have to put absolute values around it. All right? If x happened to be, say, negative 1, negative 1 to the 10th power would be negative 1 times negative 1 times negative 1 10 times. That would be a positive 1. And the square root of positive 1 is 1. But if I came over here and I plugged negative 1 in here, negative 1 to the 5th, that would be negative 1. And if I didn't have the absolute values, then it wouldn't be correct, right? Because I'd have positive 1 on this side equaling negative 1. If I do something similar on this one, this would be the square root of x to the 4th squared, which is, for the same reason, that would be the absolute value of x to the 4th. My purpose in this example, though, is for you to notice that if I have something to the 4th power, that can't be negative, right? Because if you raise it to the 4th power, it's always positive. So in this particular case, you can drop the absolute values because this right here, x to the 4th, is always greater than or equal to 0. So you really don't need the absolute values, and in this particular instance you could just drop those.